All right, welcome back for part 3 of our exciting mini-series on, hey, that's my graph. So we've already looked at how do I get an equation from the graph. That was this guy right here. And then we looked at, well, what does the y-intercept mean? And unfortunately, we decided last time that our y-intercept basically had no meaning. So we're going to cut him off the list. So now we're going to look into what does the slope mean. So we're going to focus on the slope. Well, the slope fundamentally is kind of a rate of change. It could be a number. So this is what I always ask myself. I always ask myself, how many, that's a y, I'm calling that a y, slopes do you see? All right, let's take a moment. Let's look at this. Looking at the graph, I see one line. I see one line. I see one line. Okay, so that means there are one slope. So since we only saw one slope, what does that tell us? Well, if you only see one of something and it never changes, ever, it's the same throughout, then this means the slope must be some sort of constant. All right, it's got to be some sort of constant. So we then have to ask ourselves, well, what does that mean to be constant? Well, it never changed. Okay, so this kind of means it could be one of a few things. It could be some sort of, universal constant. It just means it's a number and it's got some units on it, and it is what it is, and that's what it just happens to be. But it could also have a true meaning. So for just a quick example, let's say instead of talking about plants growing, we were talking about cars racing and the units were miles per hour. You'd be like, I think that's speed. So then it has a deeper meaning, okay? So it's either some universal constant, which is just a number and you're stuck with it, or it could be a new idea that we can actually look into and give a name to. So those are the two we're going to be looking at. So now trying to understand this, we are going to have some avenues. So first is we look at units. All right, so if I look at units, for this, the units are kilograms per second squared. So this means that I'm going to have so many kilograms, and we're talking about plant growth, so many kilograms of plant growth per second squared. So this, to me, seems like it is a rate. And a rate of what two things? Well, fundamentally, you have mass versus time. So this seems like it's going to be a rate of growth. So this is going to be kind of, how fast is the plant growing? How much mass is it gaining every second squared? So this would be a rate of growth. And so that would basically meaning. So I'm looking at the units. I'm trying to ask myself, what makes sense? All right. Another option is it could have been something that was constant from our lab. So we'd also look at some of the things that were constant in our lab. And maybe we would notice that, hey, this is about how much it grew if we squared our time. It was growing exponentially, and so that was the rate of growth. Or maybe, like I said, if it was the car example, and the units were miles per hour, and you noticed that the speed was 5 miles per hour. Like, oh, that was how fast our car was going. Or you looked at a constant in your lab. You said, hey, we always use the same mass. The units are kilograms, and we always used a 5 kilogram mass, and the slope is 4.9. So that'd be pretty close to 5, so that makes sense there too. So maybe it's that constant we chose from our lab. So sometimes it's a constant from your lab, sometimes the universal meaning, and sometimes it is another meaning that has to do with the rate of change. So those are pretty much your options. So what this means is the slope, in our case, is actually the rate of growth. So just like last time where we said, oh, the y-intercept means nothing, let's kill it. Now we're going to say, let's rename this. So really, we have a new equation now, and that's mass equals the rate of growth. I guess I could have written growth rate. All right, it's probably unique to each plant. I'm guessing not all plants have the same growth rate. Times time squared. All right, so this is a specific thing. Maybe you say rate of growth. Maybe you leave it as the numerical value. because it is, just a number. In physics, we don't have too many random things, so it might be, hey, I know you got this, and it's really close to 5, and the answer is supposed to be 5. So let's use 5 for the future. But now you have come up with basically an equation because you figured out, well, what's the y-intercept mean? Should I keep it? Should I lose it? What's the slope mean? How's that working for me? Should I keep it? Should I lose it? So you're kind of left with a final fundamental equation. All right? Thank you. Join us next week where we look into, how do I use this thing?